Hello students, today we'll study the last lecture of the chapter Force and Laws of Motion. Okay, and in this lecture we will study different types of friction. So here we know that friction means that opposes the motion of any object, right? So there are different types of friction we can see here. Now, suppose one object that is rolling on the ground, that will face one type of frictional force. And if you are sliding one object, suppose this is one object and it is just on the ground and you are sliding this one, then also it will face one type of the friction. So here in this lecture, we will discuss what are the different types of frictions we can see in our daily life. So first is the static friction. Now, the static friction is defined as the frictional force that acts between surfaces when they are at rest with respect to each other. Now see this figure very carefully. This block that you are keeping on the table. So this is the surface. Just a minute, I have to take the pen. So this is the surface, right? Over which you are keeping the block. So here you can see that the mass of the object, that is the mass of the block, that is the m. Okay. So here mass of the object, that is the m, and whenever you are keeping one block on the table, at that time some gravitational acceleration will be here, that is g. So the weight of the object, that equals to the weight of the object. I'm writing here weight of the object, or you can say block, that equals to w, and that is the mg. Okay, and where m is the mass of the block and g is the gravitational acceleration. Okay, now here you can see that if it is static on the surface of the table, at that time one frictional force will be acting in this direction. One frictional force will be acting in this direction, and that is called the static friction. Static friction. Now, if you apply the force, that is Fa, then you can see that this force that should be how much force that should overcome your static frictional force, unless you cannot move the block to anywhere. And whenever the weight in this downward direction, at that time the normal force, that is in the upward direction, as we know that normal force is 1. Okay, so the magnitude of the static force, that is equal to the opposite direction, in the opposite direction when a small amount of force is applied. So here the static force, that is equal in the opposite direction. Okay, so here static force, that is in the opposite direction of the applied force. Applied force you are applying from left to right. Here the static frictional force, that is acting from right to left. So when the force increases, at some point maximum static friction is reached. So this is the static friction. Static friction means your block or your object that is in the rest condition on a surface. It may be your table, it may be your ground, it may be any other surface, but it will be in a rest condition. At that time also you can see that some frictional force is acting just at the interaction between block and the surface of the plane. So this is the static friction. Okay, clear? Now the static frictional force, that is Fs, this is static frictional force. Okay, static frictional force, and this static frictional force, just a minute, this static frictional force that equals to mu s into mg, where mu is the coefficient of the static friction. Coefficient of the static friction, m is the mass, and g is the acceleration due to gravity. Acceleration due to gravity, generally g is 9.8 meter per second square. Okay, and mass, it depends on the block, and mu s, that is the static frictional coefficient. Static frictional coefficient, and Fs is the force, static frictional force. Okay. Now, static frictional example. Let's see the examples. One person here in this figure, you can see that he is skiing against that snow. Okay, against that snow he is skiing. So that means he is moving against the static friction and creating heat by rubbing both the hands together. In winter season, all of us, sometimes we are doing these things. Whenever so much cool weather is there, at that time you can see that we are rubbing our palm. So we are rubbing our hands together, that creates some heat. And table lamp resting on the table, that is also example of the static friction. Here, whenever the table lamp is you are keeping on the table, this one is the surface, this one is the surface, and you can see that here it will offer some static friction. Now the coefficient of static friction. Here the coefficient of static friction, that is denoted by mu s. Already I have told you in the last slide. The maximum force of static friction is given by the product of coefficient of static friction and normal force. Now here the normal force has been written by eta. Now actually Fs, that is maximum, that equals to mu s into n. Okay, mu s into n. We are writing the normal force with the help of n. Sometimes it can be written as eta. So this is the normal force, and Fs is the force of static friction. Fs max, that is the force of static friction, that is the maximum force of static friction. So static frictional force, that is less than or equal to the product of the coefficient of static friction and normal force. That's why it has been written here, Fs is less than equal to mu s eta, okay, or mu s into n. Generally, this equation we are using widely. Okay, here Fs, I'm writing it clearly, Fs max, that equals to mu s into n. Okay, generally this equation we are using widely. Next, the sliding friction. As I have told you, the sliding, sometimes we are sliding one body or object, or sometimes you can, whenever you are going to hill station and you are coming downward, right? At that time also you can see that you are sliding. So here, or any object you have in the inclined plane, suppose this is the object, and this object will slide down through this inclined plane. So here sliding friction, that is defined as the resistance that is created between any two objects when they are sliding against each other. Here you can see that the force I am applying in this direction, the friction is acting here. So sliding motion will be in this direction. So sliding friction means here you can see that there is an inclined plane. This is the one object. Another object, that is the block, you are keeping on the inclined plane. So here sliding friction is defined as the resistance that is created between any two objects when they are sliding against each other. If this block will slide down, at that time you can see that this inclined plane it offers some resistance to the block. So this resistance is called a friction. This resistance is called a friction. It is sliding, that's why the name has been given sliding friction. Next, the friction, this friction is also known as the kinetic friction and is defined as the force that is needed to keep a surface sliding along another surface. That I have told you, suppose one inclined plane is here and you have one block here, one block, and that will slide down here, it will move down here. At that time, you can see that this friction, sliding friction, sometimes we are using the term kinetic friction. Sometimes you are using the term kinetic friction, and it is defined as the force that is needed to keep a surface sliding along another surface. That means whatever the force you have to apply to the block, whatever the force you have to apply to the block, suppose this is the block and this is your, let me draw it very carefully. Just a minute. Just a minute. I'm trying to draw it in a very good manner. So let it be. Let it be the inclined plane. Okay. And here you have one block. Here you have one block. And this block will move in this direction. The sliding friction will act on this direction. Right? Now this sliding friction, sometimes we are telling this is the kinetic friction, and it is defined as the force needed to keep the surface sliding along another surface. This is the another surface, the inclined plane, and this is the first surface. So first surface means this surface of the block which is in contact with the inclined plane, right? So if you are applying the force to slide down this one, at that time your applied force should be your greater than your sliding frictional force. And it depends on two variables. One is the material and other is the weight of the object. Obviously, the weight of the object that will be acting here, this weight of the object, this is the mg, and this is very important. And another is the material. That means you are sliding iron block or you are sliding some wooden block. So it depends on different types of the material, because here you can see that if you can remember one thing, whenever we are sliding the two surfaces, that is also very important. They are polished or not. If you are sliding in a cemented floor, at that time it will be hectic. But if you are sliding through a very polished floor, that means oily floor, at that time you can see that it will slide very easily, right? So it depends on, just a minute, I am taking the highlighter. It depends on two variables. The sliding friction depends on two variables. Number one, that is the material, which type of material you are going to slide down. Another thing, that is the weight of the object. Another thing, that is the weight of the object. And any change in the surface area in contact does not change the sliding friction. Okay? Any change in the surface area in contact does not change the sliding friction. In most of the materials, sliding friction is less than the static friction. Always remember this thing, because from this some MCQs may be there. Sliding friction is less than static friction in most of the materials. Sliding friction is less than static friction. Next, the examples of the sliding friction. I think all of you have played cards. So whenever two cards you are sliding against each other in a deck, at that time you can see that there will be some sliding frictional forces acting. And whenever you are just picking one card or you are just withdrawing one card, at that time you are applying force just to overcome the sliding frictional force. Another thing that just now I have described, this is the inclined plane where some block is here having the mass, some block is here having the mass m. So this will sliding of this block across this floor, that is the example of the sliding friction, because this block, it will feel some frictional force against its motion. Okay, if it is very smooth floor, very smooth floor, at that time you can see that it will slide down very easily, right, with the amount of very small amount of applied force. But if this surface, if this surface over which it is sliding down, if this surface is not so much smooth, at that time you can see that the sliding frictional force will be here, that will be high, and at that time you have to apply more force. Now equation for the sliding friction, here for the sliding friction, your Fs, that equals to, Fs is the sliding frictional force, that equals to mu s into Fn, where Fn is the normal force. Here in this figure it has been shown that W, that is the, just a minute, that is the mg, and here normal force is this one, and here the sliding force, that equals to mu s into Fn. Mu s into Fn, where mu s is the coefficient of sliding friction, Fn is the normal force, and Fs is the force of sliding friction. Now, what are the factors that affect the sliding friction? First thing, the surface deformation of object, surface deformation of the object, that will depend. Okay, the sliding friction, that depends on the surface deformation. Suppose you have a block like this, and over a table you have this block, and the surface which is in contact with the table plane, that is very smooth surface. Another may be, suppose I am keeping one brick here, where some unevenness is there. At this surface you have some unevenness. So here the sliding friction will be different. Next, the roughness or smoothness of the surface of the objects. Now, if this incline, suppose this inclined plane, this is very smooth, and another inclined plane, that may be not so much smooth, like the hilly station path, right? So at that time also the roughness or smoothness of the surface of the object, that will depend. That means this surface also that affect the sliding friction, this surface also affect the sliding friction. The original speed of either object, right? The original speed of either object, that also affect the sliding friction, and size of the object. Finally, the amount of pressure on either object. How much amount of pressure has been given to the every object. Here, that is also important. Okay. So, first point, that is the surface of deformation of object. Second point, the roughness and smoothness of the surface of the object. Third point, the original speed of either object. Fourth point, the size of the object. Finally, the last point, amount of pressure on either object. Now, examples of the sliding friction. Already I have told you, rubbing both the hands, a child sliding down through a slide in the park. You can see there will be some sliding friction acting. A coaster sliding against a table. A washing machine pushed along with the floor. Those are the examples of the sliding friction. Now, another example, that is the frame and the edge of the door sliding against one another. Suppose you have this door and it is sliding. So this is the surface here. You can see this is the surface here that is in contact with the floor and the door. Floor and the door. So here some sliding friction will be acting. A block being slid across the floor, two cards in a deck sliding against each other. Already I have described this in the earlier lectures, earlier slides. Now, Mr. Question Uncle, what is sliding friction? First question is the what is sliding friction? The force needed to keep a surface sliding along another surface is known as sliding friction. Okay. What are the two conditions on which sliding friction depends? Obviously, already we have, just a minute, I am just changing the color of the pen in color. One is the type of material, another is the weight of the object. One is the type of material, another is the weight of the object. What is the formula for calculating the sliding friction? That is Fs equals to mu s into Fn, where Fs is the sliding frictional force, mu s, that is the coefficient of sliding friction, Fn, this is the normal force. Okay. Now give two examples of the sliding friction. Whatever the try to give examples which you are seeing around yourself in your daily life. Always remember one thing, that in case of physics, we are seeing every time around ourselves, we are seeing some examples, but we are not noticing now. But I think that after reading all these lectures, you can see whatever is going around you. Okay, whatever is going around yourself. So at that time, sliding friction, a coaster sliding against table. If you are playing the card, you can give the example of the card. If a block that slide across the floor, being slid across the floor, that also can be example of the sliding friction. Now next question is does roughness or smoothness of the surface of the objects affect the sliding friction? Now this question answer that is from the slide, whatever I have given you, what are the things that affect the sliding friction? Yes, sliding friction depends on the roughness or smoothness of the surface of the object. I have given you the example of brick and one very smooth wood block. Now the rolling friction. Rolling friction is defined as the force, just a minute. Rolling friction, this is defined as the force which resists the motion of a ball or a wheel. Now you can see that if you have a car wheel here, this is the center, and you have, if it is for cycle also, so here also it will resist the motion of the ball or wheel and is the weakest type of friction. Rolling friction is the weakest type of friction. Rolling friction is defined as the force which resists the motion of a ball or wheel, and it is the weakest types of the force. Frictional force. For a moving solid body, there are two principal types of friction acting on it. The force resisting the motion of a rolling body on a surface, that is known as rolling friction, and rolling of a bar or wheel on the ground, that is also an example of the rolling friction. Now, you can see that in your car, the wheel is moving. So with respect to this center, the wheel is moving here. So this will offer some rolling friction. Another thing, the car will move from this position to this position. How? Because your wheel that will slide from this position to this position. But at the time of sliding this one, you can see that always your wheel is rotating. Always your wheel is rotating with respect to the center, right? So that means there are two friction is acting on it. One is the rolling friction, another is the your linear. For the linear motion, whatever the force that resists the linear motion, that friction is also acting on it. Okay. Now, rolling friction, here the sliding friction that I have told you, whenever you are moving your car wheel from one area to other area, at that time there it will slide. Okay. So sliding friction is also acting on it, and there is some restrictions on the body's movement as only one side of the body is in contact with the surface. Okay. Rolling friction is considerably very weaker than the sliding friction. Weaker than the sliding friction. This is the example of the friction. Here you can see that wheels moving of the vehicles. Here push on the wheel you are applying and wheel rolls forward. So the friction here in this direction you have that resists the rolling. And rolling of the log on the ground also, that is an example of the rolling friction. Here you can see that the person who is cycling, this tire, it has a rotating movement, right? With respect to this center. With respect to this center, this tire has a rotating movement. So the rolling friction will act here. But whenever it will move somewhere, at that time it will slide also simultaneously. At that time, sliding friction is also acting on the tire of the cycle. Okay. Here it is very clear, sliding friction and rolling friction. So here you can see he is trying to slide some object, and here sliding friction is acting, and here you can see that some rollers are there under the object. So it is very easy to push that thing, rolling friction, because the rolling friction is less than the sliding friction. Right? Rolling friction is less than the sliding friction. So you can see that this man, our grandfather, this man is very easily moving this one. Whether this man has to put a large amount of force to overcome the sliding friction. Okay. Now, laws of rolling friction. Here, with the increase of smoothness, the force of rolling friction decreases. If your surface is very smooth, through which your car wheel is moving, or through which your any log will move, at that time you can see that the rolling friction decreases. Rolling friction force is directly proportional to the load and inversely proportional to the radius of curvature. Now suppose you have one block here. Suppose you have one block here, and the radius of curvature, that is R. So here the rolling frictional force, that is directly proportional to the load or the weight of the object and inversely proportional to the radius of curvature. Radius of curvature. Just a minute. Here W, that is the weight of object, and R, that is the radius of curvature. And in this figure, from this center to this point, this is the radius. And here F is the rolling frictional force, and mu is the coefficient of rolling friction. Okay, so here in this figure you can see that this is the wheel, and here from center whatever your this is the radius, and weight is this one, where W, that is the m is the mass of the object, and G is the acceleration due to gravity. So if we are applying some force, then it will rotate, right? And the rotational velocity, let it be omega. So translational velocity also acting this one, that is V, and rolling friction Fr will act on this direction. Okay, rolling friction Fr will act on this direction. So rolling friction force, I can write down this as Fr. Rolling friction force. Rolling friction force, that is directly proportional to W, that means load, and rolling frictional force, that is inversely proportional to the radius of curvature. Okay. Now, what are the factors that affects? The amount of friction is based on variety of factors here. First one, the quality of sliding body, the quality of the surface load, the diameter of the rolling object, the surface area of the body. These are the 4 points you have to remember. For the rolling friction, this will affect the quality of sliding body, the quality of surface load, the diameter of the rolling object, the surface area of the body. Now, coefficient of rolling friction, here the coefficient already we have described in the previous lecture. Mu, just it has been replaced by mu r. So this mu r is the coefficient of the rolling friction, and it is nothing but Fr divided by W. Okay, where Fr is the rolling frictional force, W is the weight of the object. Rolling friction example, basketball rolled over on the court. Bike with the broad tire will burn more fuel because increasing the rolling friction. A ball rolled on a field, that also faced some rolling friction. So these are the examples of the rolling friction. Now, what is the difference between the rolling friction and the sliding friction? Rolling friction takes place when the object rolls on the surface. Sliding friction takes place when we are rubbing two surfaces. Rolling friction takes place due to the deformation of surfaces. Sliding friction takes place due to the interlocking between microscopic surfaces. The coefficient of rolling friction dependent on the radius of the rolling object, the depth to which the object can sink, the toughness of the surface. Whereas the coefficient of sliding friction depends on the texture of the surface and temperature to a certain extent. And coefficient of rolling friction, that is mu r into n, and coefficient of sliding friction, that is mu s into n. Okay. Now, what is friction? Friction is the force that opposes the rolling or sliding of one solid body over another. Or you can say in very simple word, friction is the force that opposes the movement of any object. What is meant by kinetic friction? Kinetic friction is the friction that acts between moving surfaces. What is meant by static friction? Static friction is the friction that acts between two stationary surfaces. Rolling friction is the force opposing the movement of a rolling object on a surface. Give example of the rolling friction. A lot of examples you have in your daily life. From that, just you pick any one. A football rolling on the ground, you can give any rolling friction example. What is fluid friction? Fluid friction is defined as the friction that exists between the layers of the fluid when they are moving relative to each other. Fluid friction generally for the swimmer, it will be acting. But one thing you should remember for the fluid friction, that is viscosity. Viscosity. That is very important because it depends on the viscosity. Examples of the fluid friction, the flow of ink in the pens. Always you are using pen, swimming. These are the examples. Now, what is the static friction, sliding friction, rolling friction? Give two examples of sliding friction. All these questions already we have discussed in each and every slide. What is sliding friction? Define rolling friction. Give two examples of sliding friction. Always I am requesting you, whenever they are asking for example, try to give example from your daily life. Okay, now there is a matching here. Fine. First is that in the column 1, just a minute. Okay, in the column 1, we'll write the answer here. In column 1, action and reaction. So which one is correct here? First is balance force, no. Newton's first law, mass, Newton's second law, inertia, Newton's third law, right? So action, Newton's third law, it has been stated that every action has the reaction. So for A, the correct answer is that 6, that is Newton's third law. Let's solve for B. Here, cricket player lowers his hand while catching the ball. Okay, this example already we have described why he will do this thing. Here, cricket ball, first one is balance force, Newton's first law, mass, Newton's second law, inertia, blah, 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 blah. So here, it will be your Newton's second law. Sorry. I don't know. Sometimes the pen is drawing it itself. I think it likes to draw. So this is 4. Next, so this done, this one done. Rocket propulsion. Rocket propulsion. See, rocket propulsion, that will be our conservation of linear momentum. Conservation of linear momentum. Okay. Then D. Resultant force is 0. Resultant force is 0. That is balance force. That is called balance force. E. A ball thrown upward in a train moving with uniform velocity returns to the thrower. Returns to the thrower. This is for Newton's first law. Then F. SI unit of momentum. Very easy. Very easy. SI unit of momentum, that is kg meter per second square. Or I can write down, sorry, I have to write down the perfect point of the answer. So that is 8. Okay. Next is G. Tendency of a body to resist change in its state of motion or rest. That is called inertia. Inertia does not allow to change its state. Then H. Inertia of a body depends on it. The inertia of a body that depends on its mass. Because more mass, that means more inertia. Okay. So already we have given one example of a fatty people and one thin people. The fatty people has less velocity, where the slim people has higher velocity, right? Thank you.